Hi student, in this unit I am going to discuss about the exceptional behavior of second period element in the 13th groups. The element present in the 13th group is boron, aluminum, gallium, indium, thallium. Exceptional behavior means anomalous behavior of boron. Boron, the first members of group 13 shows anomalous behavior as compared to aluminum and other members of the group. It is due to the following reason. The reason number one is boron has the smallest size in the group. It has high ionization energy. It has highest electronegativity. It does not have a vacant d orbital in its valence shell. Therefore, in 13th group, boron show anomalous behavior. We are going to discuss about the anomalous behavior of boron. That is, what is the difference between the boron and other elements in the same group. The first one is metallic character. Boron is typically a non-metal, while other members of the group have a typically metallic character. Thus, boron is a non-metal and a semiconductor, while aluminum and other members are good conductor of electricity. Second point is allotrope. Boron has two allotropic form, crystalline and amorphous. Aluminum does not show allotropy. Then melting point and boiling point. The melting and boiling point of the boron are much higher as compared to those of aluminum and other members. This is because of its small size and efficient close packing of atom in the crystal lattice. Then chemical reactivity. At ordinary temperature, boron is much less reactive than other members of the family. This is because of its high value of ionization energy. Then nature of the compounds. Because of small size, high ionization energy and high electronegativity, boron forms covalent compounds while aluminum form both covalent and ionic compound. Thus, AlCl3, AlBr3 etc. are covalent, while AlNO3 twice, Al2SO4 thrice, AlF3 etc. are ionic compound. Then maximum covalency. Boron shows a maximum covalency of 4 in its compound, while aluminum shows a maximum covalency of 6. For example, AlF6 3-. This is because aluminum has vacant 3d orbital which can be utilized in expanding of valency. Then hydrates. Boron forms a number of hydrates called boranes. These are volatile and covalent in nature. BH3 is unstable. B2H6 has a stable bridged structure. But AlH3 X times is polymeric, which is non-volatile solid. Aluminum also forms a complex hydrate like lithium aluminum hydrate. Then halides. The halides of boron and aluminum are covalent in nature, but the halides of boron, for example, BF3, BCl3, BBr3 exist as a monomer, while AlCl3 exists as a dimer, Al2Cl6. Then nature of oxides and hydroxides. The oxides and hydroxides of boron are slightly acidic in nature, while those of aluminum are amphoteric in nature. Those of other elements are basic in nature. That is, B2O3 and BOH thrice are acidic, Al2O3 and LOH thrice are amphoteric. Action with steam. Boron does not react with steam, but aluminum and other elements decompose in steam. Then reactivity towards acids and alkalis. Boron is unreactive when comes in contact with acid and alkalis at a moderate temperature, but aluminum react with mineral acid and aqueous alkali, thus show amphoteric character to produce hydrogen gas. That is, aluminum react with HCl to give AlCl3 and hydrogen. Aluminum also react with H2SO4 to give Al2SO4 thrice and hydrogen. Aluminum react with NaOH to give NaLO2 plus hydrogen. That means aluminum react with both acid and base. Therefore, aluminum is amphoteric, but boron does not react with any acid and base. Here one exception is that aluminum is amphoteric, it reacts with both acid and base, but aluminum does not react with concentrated HNO3. because when aluminum comes into contact with nitric acid, an impervious layer of aluminum oxide is formed. This layer of aluminum oxide will prevent the nitric acid from coming in contact with the inner aluminum metal. Thus this layer protect and prevent further reaction. Therefore we can say that aluminum does not react with the HNO3. Okay, thank you.